in this question, we have that one can use 3 different transports which move at 10, 20, and 30 kilometers per hour respectively. To reach home from A to B, Amal took each mode of transport 1/3 of his total journey time, while Bimal took each mode of transport 1/3 of the total distance. The percentage by which Bimal's travel time exceeds Amal's travel time is nearest to how much? Now, what we can do here is, we can take variables, but that will make the question unnecessarily complicated. Okay, that's not the right way to solve, of course. We have different situations for both of them. And only the distances are the same. But of course, they'll have different speeds, different times, different ways in which they are covering the distance. So I'll show you one way in which we can solve it, which will not be too difficult, but then we'll look at the shortcut, and that will make the question very, very fast to solve. So the first way I'll show you is, for Amal, we can first find out the average speed. How? So Amal is traveling each mode, each distance, 1/3 of his total time. So let us say that each of the 3 distances that he's traveling for the overall distance, each of the 3 distances, let us say he's taking the time of t, okay, because the time has to be the same. For if it's 1/3 for each of them, 1/3, 1/3, 1/3, so same time for each of them. So if we have time of t, then for the first distance, speed is 10 and time is t. So the distance will be 10 into t, speed into time. Second distance similarly will be 20 into t. And third distance similarly will be 30 into t. So that will give us the total distance. And if we divide it by the total time will be, of course, t. So that will be 3t. So we'll get 60t by 3t. So that will give us 20 kmph, A's average speed. And for B, for Bimal, we can find out the total time directly. Let's see how. See, for Bimal, we want the same distance. Each of the 3 distances has to be the same, okay, because each mode of transport 1/3 of the total distance for him. So now, the distance, we want to make it divisible by the speed. So let's assume a distance which is divisible by each of these 3 speeds. So LCM of 10, 20, 30 is 60. So let's assume each of the 3 distances to be 60. So first of all, distance of 60 with the speed of 10, 60 by 10 will be the time. Then 60 distance, speed of 20. And then 60 distance, speed of 30. So this will give us the total time for B. If the distance is 60, 60, 60. So that will give us 6 plus 3 plus 2, which is 11. 11 hours. And now the distance that we have assumed for B, we can assume the same distance for A and get the time for A. Okay, so the time for A will be the distance of 60, 60, 60, which is 180, divided by A's average speed of 20 for the entire journey. So 180 by 20 hours, so that will give us 9 hours. Okay, so we have 9 hours for A, 11 hours for B, and now we can just find the percentage increase from 9 to 11. 9 to 11, the increase is of 2. So we have 2 upon the original value 9, smaller value 9. And then 2 by 9, 1 by 9 is 11.11%. So 2 by 9 will give us 22.22%, which will give us answer to be option 1. Okay, because we have to find the option which is nearest to the final answer. Now see, while this method is not very complicated or very time consuming, there is a better, faster method, which is basically a shortcut. See, for example, here we could see for A that his average speed of 20 is nothing but the arithmetic mean of the 3 given speeds, the simple average. Why? Because there is a shortcut. It's based on logic that if you are traveling each of your distances and taking the same time for all of them, then your average speed will come out to be the arithmetic mean of your individual speeds. And for B, what we'll get is that since B is traveling each of his distances and the distances are equal, so when you're traveling equal distances, then your average speed will be the harmonic mean of your given speeds. Okay, so using that shortcut, what we can say is for A, the average speed, okay, let's just look at the average speed for both A and B. So for A, the average speed would be arithmetic mean 10 plus 20 plus 30 divided by 3 because we have 3 values. So A, we would get 60 by 3, which is 20 kilometers per hour. And for B, average speed will be the harmonic mean. So we have three values, we have three speeds. So we would get 3 divided by 1 by 20, 1 by 10 plus 1 by 20 plus 1 by 30. Okay, now if we solve this, we'll get 3 divided by 10, 20, 30, LCM is 60. And we'll get 6 plus 3 plus 2, which is 11. Now 60 into 3 will of course become 180. So we'll get 180 by 11 kilometers per hour. Now we have the speeds. Now we need to compare the times. So we can just look at the ratio of speed and time. If speeds are 20 is to 180 by 11. Okay, then first cancelling off with 20, we will get 1 is to 9 by 11. And then multiplying with 9, we will get 11 is to 9. So if this is the ratio of the speeds, ratio of the times will be 9 is to 11. Doesn't matter. One time will be 9, one time will be 11 in the ratio. Okay, it's just reversed. So we can see that since we need percentage by which one time exceeds the other time, is more than the other time, that's a percentage increase. So here the increase from 9 to 11, that is an increase of 2. So we have increase of 2 upon the smaller value of 9. And 2 by 9, of course, will give us 22.22%. So the answer will be option 1. Okay, so keep this shortcut in mind for these questions. Remember, when the times are the same, then the average speed is the arithmetic mean of the given speeds. And when the distances are the same, the average speed is the harmonic mean of the given speeds. And now try out this replica question using the same shortcut. Let us know your answer in the comment section.